Let's take a look at an example using piecewise functions. Remember, piecewise functions are individual functions where we're giving each function a domain restriction, and then we're stitching them together to create a new function. So in this example, we're talking about P of k, and P of k, you'll see, has a total of 3 pieces that are being stitched together. Our first piece, I'm going to call this piece 1. Alright, we've got P of k is equal to k squared plus 1, and these are your domain restrictions that you see off to the right hand side, right? So we're only going to be using this piece for values of k between -7 and -4, and you'll see that we're allowed to use it when values are equal to -4, but not with a value that is equal to -7. So I'm going to go ahead and write this with interval notation just so we can see it in both formats. Okay, so everything from -7 to -4, including the -4, is part of our domain restriction for that piece. Okay, and let's take a look at our first example here, because we're doing P of -6. And you'll notice that -6 appears in this interval, right? It's a number between -7 and -4. So we're going to end up using piece 1 to calculate this value. And you're going to want to substitute that -6 into that formula for P of k every time you see a k. Right? So this is going to become -6 squared plus 1. -6 squared is going to give us a positive 36. We'll add 1 to it. This will give us a final answer here of 37. The next piece in our function, piece number 2, right, is the equation P of k equals -4k plus 3. Right, and we're going to be using this piece anytime we have a k value between -4 and 1. Okay, let's go ahead and write that with interval notation. Got from -4 to positive 1. We can bracket the 1, right, since it's allowed to be equal to 1 based on that domain restriction. And we'll have a parenthesis on the -4 since there's no equal to bar there under the inequality symbol. So let's go ahead and look at our second example here, which is P of 1. Right? This is your value for k. And you'll notice that we had the bracket on the 1 or the equal to part when we're looking at the inequalities. So whenever we have a value equal to 1, that's in that domain restriction piece, piece number 2. So we can plug it into that function that's associated with piece 2. So -4k plus 3. And we're going to substitute it every time you see the k. So we've got -4 times 1 plus 3, which will give us -4 plus 3, or -1. Let's go ahead and do our next one, which is P of 2. Remember, this is your k value. Right? And when you're looking at our domain restrictions up there, you'll notice that 2 is not in any of these domain restrictions, right? Because our third piece, piece number 3, we're using the function P of k equals 1 minus 3k. And the domain restriction on this one is for k values greater than 3. Right? So in interval notation, we've got a parenthesis on the 3. This is going all the way towards positive infinity. Right? The infinity is always going to get a parenthesis there. And 2 is not in that interval. Right? So it's not in the interval for piece number 3. It's not in the interval based on our domain restrictions for piece number 2 or number 1. So this one we're not going to be able to do. Right? It's not in any of our domain restrictions. So this one does not exist. And you can write that as DNE. And that's because 2 is not in the domain. So let's take a look at our last example there. We're doing P of 4. 4 is in the domain of piece number 3, right? It's a number greater than 3. So we're going to use the function for P of k, 1 minus 3k. And we'll substitute the 4 every time we see the value for k. And this can give us 1 minus 12, which will be negative 11.